is Brianna McColgan, and I'll be doing 2007 BC number 4. In this problem, you'll need to know how to do integration by parts, how to find a constant and an integral using initial conditions, and how to use the equation of the tangent line. Okay, so let f be the function defined for x is greater than 0 with f of e equaling 2, and f prime, the first derivative of f, given by f prime of x equals x squared ln x. So A, write an equation for the line tangent to the graph at f at the point e, 2. So if you have your coordinate and your equation for a tangent line is y minus y1 equals parentheses x minus x1. Your y1 equals 2. Your x1 equals e from those points. And your m is your slope, which is your derivative. So the derivative is given to us as f prime of x equals x squared L and x. And you just plug in your x value. So f prime of e equals e squared ln e, which cancels out to be 1. So f prime of e is just e squared. So you just plug all these in, and you get y minus 2 equals e squared, parentheses, x minus e. And that's it. So for part B, it says, write an equation for the line tangent, is the graph of f concave up or concave down on the interval of 1 to 3, and give a reason. So they give you f of x, f prime of x, I'm sorry, and that's x squared ln x, and you have to take the derivative, so you have to find the second derivative, and you'll use product rule, so you'll get f double prime of x equals 2x ln x plus x squared over x, which just becomes x. So you have f double prime of x equals 2x ln x plus x. And ln of x always has to be greater than 0. So it's concave up on your interval. And the final part C, is use anti-differentiation to find f of x. So, okay, so you have f prime of x is equal to x squared ln x, and you just want to take the integral of f prime of x. So x squared ln x dx. And you have to use integration by parts. So we do u, v, du, dv. And ln x is your u, derivative over x, x squared, x cubed over 3. So you have your uv minus your v du, so that'll just be x cubed over x, and you can pull out the 1/3, so just looks nicer. And this is just x squared. So, here we dx. Okay, so when you simplify it, it's x cubed ln x over 3 minus 1/3 the integral of x squared dx. And when you solve, it just looks like x cubed ln x over 3 minus x cubed over 9, because the antiderivative of x squared is just x cubed over 3, and 3 times 3 is just 9, plus c. And we have to find c, so going back to our initial conditions of e comma 2, we're just going to use our x and y values to solve for c. So we know that when you plug in e, you should get 2. So we'll just plug in e for everywhere we've seen x. So e cubed ln e, which just becomes 1, over 3 minus e cubed over 9 plus c equals 2. And so we're just going to solve for c. So that's just e cubed over 3 minus e cubed over 9. So we just multiply by 3 right here. Plus c equals 2. And we'll get 2e cubed over 9. And we'll subtract a 2. Saving the step. So we found c, and now we have to plug it in up here. So I'm going to erase the top part real quick so we can just put it up here because it's long. Okay, so it becomes x cubed ln x over 3 minus x cubed over 9 plus 2 minus 2e cubed over 9, and that's your f of x. And these are your scoring guidelines.